Alright, so today, October 13th, we did a warm-up. Jot down, or here are the problems that we did in warm-up right here. And right here, quadratic formula, and here's the results. I'll post this on our classroom. The two problems we did as warm-up. And then the new material, this is 3.4 new material. We have an equation that represents the projectile of an object. So basically, if something gets launched in the air, this is the equation we use, where h is height, t is time, v sub 0 is your initial vertical velocity, and h sub 0 is your initial height. Okay, so our problem was we wanted to launch the Stay Puft Marshmallow Man with an initial vertical velocity at 200 and an initial height of 5 feet. So 200 is your v sub 0 and 5 is your h sub 0, so there's our equation. From here, we manipulated our calculator screen to eventually get it to appear on our calculator by zooming out and adjusting the window. And this is the window settings that we're at, that I ended up with, but people have different settings depending on what worked for them. And now we're answering questions. How high after 2 seconds? So I've given the class some time. What are we doing for this? How high after 2 seconds? What do we have to do? Good. Calculate value. 2 seconds. So we're going to use a calculator. There's my graph. I'm going to calculate value. We want to know what the height is after 2 seconds. And is that 341? That's going to be messy. Alright, so Stay Puft Marshmallow Man after 2 seconds is at 341 feet. Make sure you do the label, the units. Maximum height is the next question. So we want to know what the maximum height is. So go ahead and use your calculator to do that. We want to know how high he ends up going. So calculate maximum. So we're looking for this right here, the maximum, the vertex. So left bound, we go on that side of it, and then right side, and then guess it. So what's that say, 630 feet? Yeah, that's what we got. All right. So maximum height is 630 feet. Now we could have done this by hand. To find that vertex, it's in standard form. You'd have to do negative b over 2a. So it'd be negative 200 over 2 times negative 16. That'll give you the x value of the vertex, whatever that turns out to be. And we'd plug that into our equation to find what the y value. Whatever you get, the y value would be 630. So negative b over 2a is the x value of the vertex. Plug it in, you'll get 630. How long is it in the air? Okay, so he's up, getting launched until we get to right there. So we want to know at what point does he land. So go ahead and figure that out.
Something you don't see every day. Like it's the most harmless thing. Something I love from my childhood. something that could never ever possibly destroy us. Mr. Stay Puft. Nice thinking, Ray. We used to roast Stay Puft marshmallows by the fire at Camp Wakanda. Ray has gone bye-bye, John. What have you got left?
Sorry, Venkman. I'm terrified beyond the capacity for rational thought.
How long was it in the air? Who's got an answer for me? Ian, what'd you get? 12.52? Is that what you got, Annika? So 12.52 seconds. I like that you did the units there. We found that by calculating the 0. Left bound, right bound, guess 12.52 looks good. And then when was it 40 feet high? Last question. So what we can do is we can use our calculators. A couple ways we could do it. I think for right now, what we do, if 40 feet is our value, that's our, is that height or time? 40 feet. Is that our height? That's our height. Okay, so we're going to put 40 in for h. So 40 equals negative 16t squared plus 200t plus 5. And now we can solve that equation. Okay, so we can subtract 40 and we get a new equation that we can solve by graphing on our calculators. I'm going to show you, I think, a different way, a better way of doing it. So I would not do it that way. I would say, let's find the point of intersection of y equals 40 and y equals, well, the equation that we already have. And that's what we're going to end up doing in 3.5 anyways, solving systems of equations. So let's type in y equals 40 and graph it. How many times is it 40 feet high?
One time.
It's one time here. Yeah, and then on the way down also. Okay? So I might as well show you how to do this because we're going to do it later today anyway. So we can find those points of intersection using our calculator. So calculate. What do you suppose we're going to do now? The intersection. So intersection, it asks for first curve. So there may be 3 or 4 curves on there. If that's the case, you have to choose which curve. You can always go up and it bounces to the other curve. But really, we only have 2. And when it says curves, it counts lines as curves. So I'm going to just choose, that's my first one. That's my second curve. And then guess is right on the intersection point. And I got 12.32. So 12.32 seconds. And go ahead and use your calculator to find that other point of intersection. It happens twice. So calculate intersection and find that point of intersection. .18 or so. So 0.18 seconds and 12.32 seconds is when it is 40 feet high. Questions on this? Alright, so I'll give you some time to work on your 3-4 assignment, and then we'll start 3.5. And if you understood the last part of 3.4 here, like the intersection, 3.5 is a lot of calculator work in doing that, so you're in pretty good shape if you understood that.